Good afternoon, student. Welcome back to new series of lectures on electrochemistry. After this chemical kinetic series, now I am planning to prepare some lecture related to electrochemistry of your course. As you know that in second semester of M.Sc chemistry, there is a separate unit on electrochemistry. And if you go through our syllabi, you will find that you have to study various theories related to electrical double layer, or sometimes we call it electrified interface, because suppose there is an electrode and it is dipped in a electrolyte solution, and you know that there exists an interface between the electrode and that electrolyte, different charge ions, and there is a large number of theories. So I thought that before I derive all those important theories like Helmholtz theory, Gauss and Chapman theory, as well as the ultimate theory as we call it, Stern theory, because neither Helmholtz theory nor Gauss Chapman theory can explain this capacitance and other things, and therefore we have to study the Stern theory. Now it is necessary that before going into details of this theory, you must understand some of the fundamentals of electrical double layer. And what about the electrified interface? So very briefly in this lecture, I will explain the fundamental concept, and if you understand these fundamental concepts, you can easily derive any theories related to that electrical double layer theory. And I am planning to discuss some of the salient features of this theory, although I will not derive today in this lecture, but I will categorically explain the basic difference between these three theories, and then in part 2 or part 3 I will derive the Gauss-Chapman as well as the Stern theory. Now before I go into details, as you know that I am using that facilities of our Pandit Ravi Shankar Shukla University, and that is lecture capturing theatre of School of Studies in, you can see, Mathematics department, and I am really grateful to Professor Balwant Singh Thakur, the head of the department, and his colleague Dr. Dipti Thakur and Indra Kumar, and my student Mr. Abhishek, who always helped me in preparing all such type of lectures. Now you know that now, as per the national education policy, we are giving more trace on research oriented teaching, and you are all aware of this one nation, one subscription. Any student can access any journals of an American Chemical Society or Elsevier or Royal Society of the Chemistry, And you'll be glad to know that this is a very important topic nowadays, electrified interface, because if I am talking about the electrocatalysis, if I am talking about the corrosion, if I am talking about the fuel cells, nanoparticles, supercapacitors, everything based on these fundamental concepts. And there are a large number of very good articles. I am not saying that you go all those papers, but if you are interested, so you can see some of the important review articles related to that electrified interfaces. And one of such article is chemical reviews, understanding the electric double layer structure, capacitance, because that is the ultimate objective. And in addition to that, you can refer your standard electrochemistry book like Bocchus and Reddy, which is the best book. Modern electrochemistry like Glaston and other your normal textbook. And I also referred very recent article published in January 2026, 1st January 2026 on this, and one Acta Physico-Chemica Science published in May, interfacial electrical double layer in electrocatalytic reactions. But don't worry, I will not discuss the research methodology or research orientation. I will only give the actual meaning of that, what does it mean, why it is called electrified interface, what is actually electrical double layer, what is diffuse layer or compact layer, like that. But I will also request all the students, please go to this very recent article, chemical reactions at electrified interface, because you have to also study that electrocatalysis. And in order to fully understand of the Gauss-Chapman layer, you must know some of the statistical thermodynamics, Boltzmann distributions, and some postulates of the Debye-Huckel theory, because I have already prepared the Debye-Huckel lecture notes on the Debye-Huckel theory. Anyway, so now I will start this thing. And you also know that there are some of the important COPUs, course objective, program outcomes, like that. So the first question is that why do we study this electrified interfaces? So the first point is that you know that nowadays people are working on the catalysis is one of the most important part. Corrosion is also most important part. And although you are students of the chemistry, but these electrical double layer theory or even electrified interfaces are crucial for many studies in physics, chemistry as well as the biology. Various biological systems or nerve conduction, you all know the membrane, role of potentials and different ions is also very important. Then it has a significant role in the catalytic activities in the chemical and industrial processes. That is also very important. As well as that, you know that energy storage is one of the most important concepts nowadays. How we store that energy, and I think you are all aware of the definition of the capacitance. How energy is stored, that is also important. Different types of lithium-ion batteries, sodium-ion batteries. There is also the role of electrolytes, the different types of metal electrodes, like that. So I can call it, this study is called the next generation capacitor technology. So now you can understand the importance of the subjects. Then also it will facilitate the ion transport in electrochemical system. You know that it's very important in biological system. It can also use in different environmental technologies like water purification, environmental remediation technology, and of course renewable energy technologies. And now we are all talking about the nanoparticles as well as the semiconductor devices. So that is the importance of that electrified interface. The course outcome, the program specific outcome is that after studying this whole electrochemistry and particularly the introduction part, you are able to understand different theories like that. So first question is that what is a single name itself is a definition. मतलब आप कैसे define करेंगे simple language में? What is electrified interface? Interfaces you can understand. Suppose there is an electrode, metal electrode is there, I can call it any time. And electrolytes are also there. Suppose I am using sodium chloride, I can use different color sodium. Chloride is also there. Negative ion. Plus, minus, here is some electrostatic interaction, negative, plus, minus, different types of electrodes. So, the interface part. So, electrified interfaces consist of an electrode and a liquid or solid liquid. It is a simple definition. And why it is called the electrical double layer? And you know that this distribution of this, there is a cation or an anion, these are unequal distribution. And there are two layers. One is charged electrode surface. Here I am just giving the large potential is the positive charge. This is the first layer. And of course, second layer is the accumulated counter ion point. So one is electrode surface, another is the electrolyte. So therefore it is called the electrical double layer. आप बोल सकते हैं electrified interface or now it depends. What about the thermal motion of the ion? What about the change in potential? What about the role of dipoles? What about the role of dielectric constant, valency of the ion? That has to be studied. But you can call. So these two layers together form the electrical double layer. And who invented first? Long back, I think Helmholtz. Credit goes to great scientists. Most of the scientists are physicists. They published this paper long back, 1853. You see, this is the original research paper, of course, in the German language. So therefore, we'll first study what is the Helmholtz double layer. It is just like a simple parallel capacitor. This is a positive electrode and negative ion. So it's just like this. But when an electrode comes into contact with an electrolyte, जब इसको थोड़ा ध्यान से सुनिए क्योंकि ये यहीं से थ्योरी स्टार्ट होता है. सपोज ये मेरे हाथ में इलेक्ट्रोड है एंड आई जस्ट dipped in electrolyte and that electrode is gradually touched with that electrolyte under an applied voltage. So charged particles and dipoles at the interface experiences different forces. And we have to calculate that forces. What about this different types of forces? And this interfacial double layer is the key area where electrocatalytic reactions occur. And as a result of these different forces between electrode, surface and electrolytes under this applied voltage, this charged species rearranges. You know, regarding the biological theory, sometimes in central there is a cation and the cation is surrounded by an ion. It depends upon the various factors. So there are some positive ions as well as the negative charges and separate and dipole to align the specific direction. So that is a very crude definition of electric double layer, EDL, or electrified interface. Because why these theories are important? Because they explain how that electric charge are distributed. That is the important point. So therefore again we need the statistical thermodynamics, Boltzmann distribution, Poisson distribution. आपने इलेक्ट्रोड को डाल दिया, इलेक्ट्रोलाइट के साथ टच हो रहा है, डेवलपमेंट ऑफ फोर्स, डेवलपमेंट ऑफ द चार्जेस, but how that ions, and there is a redistribution of the ions, there may be electrostatic attractions and there are so many other forces are there. So how do we study the distribution at the interface between the solid surface and a liquid electrolyte? And therefore, why such theories are required? क्यों इन सारे सिद्धांत की जरूरत है? Because this interfacial capacitance of a metal electrode in contact with dilute electrolyte is generally studied by the different theories. There is a force, everything is there. Now, how that interfacial capacitance, I hope that you know the actual definition of the capacitance, storage capacity. So what are these theories? Theories are nothing, just to determination of that capacitance and that charge distribution between that metal electrodes and that electrolyte. And that can be studied with the help of Ghosh, Chapman and Sternberg. Now, I am coming various factors. Number one is that interface between electrode and electrolyte. The reason, इसके बाद मैं कुछ photographs दिखाऊंगा, then you can understand the actual definition of the interface. How that potential is, potential of the metal and potential of that solution. Is it dropped linearly or it is exponentially, or सबसे पहले linear होगा, फिर exponential changes होगा, और gradually drop changes होगा. So the region where a solid electrode touches a liquid electrolyte is called the interfacial region. And bear in mind that this interfacial region is heterogeneous. It is not homogeneous, inhomogeneous region. क्योंकि इज नॉट इक्वल. देखेंगे अलग अलग, समटाइम्स एनान्स की डोमिनेंस है, कभी कैटायंस की डोमिनेंस है. सेकेंड, दिस inhomogeneity is in the effect of interfacial region. Now it depends upon many things. It depends on the electronic density. The charge or the electrons on the electrode surface is not evenly distributed. मैंने पहले भी आपको बताया. It varies depending on the potential and the surface property. And also it depends on the solvent. Most of the time we are using the water. And if you understand the Debye-Huckel theory, अगर आपने पढ़ा होगा तो आपको याद होगा, there is a concept of thickness of ionic atmosphere, where temperature plays a very significant role, the dielectric constant plays a very significant role. Ions in the solution, positive or negative, are not evenly spread near the surface. And solvent molecules also arrange themselves. इसलिए इसको solvation of ions बोलते हैं. Because sometimes what happens, when suppose I am talking about the positive electrode and there are some ions are adsorbed on the surface of the electrode, which is very near to that electrode. Sometimes it is called the Helmholtz ion plane, but sometimes inner plane. And another is the Helmholtz outer plane, which is away from that electrode, and there is a process of ion solvation. मतलब अगर आपने यहाँ पे मैंने ये लिखा, that is electrode surface, and here is suppose negative anions is there, and this is called the inner Helmholtz inner plane, and away from this, suppose there is a water, and if I am just ये मैं water का बना रहा हूँ, so that is called the solvated ion. ये भी distributed अलग अलग, ये solvated cation. Solvated cations मैं आपको दिखा रहा हूँ. Water का अलग अलग ढंग से भी water is also spread out like that. So it is very near, adsorb on that surface, that is called the inner Helmholtz plane, जो outside में है, it is related to the solvated ion. That is also called the outer. So solvent molecules also arrange themselves in an ordered form. I think you can understand these things. I'll show you some of the diagram like that. Now, behavior of the ions near the electrode. So there are two types of things. One is the counter ions. What does it mean of the counter ions? If it is electrode is positive, that ions are there like that. So ions with the opposite charge to the electrode, they are attracted towards the electrode. So naturally, अभी थोड़ी देर पहले आपको बताया. And there is a change in potential, positive potential also negative potential, and they accumulate near the surface. And what about the coions? Ions with the same charge as the electrode, maybe positive, negative, that is surrounded here, random distribution. And water solvated is also there, and they are repelled away, and their concentration near the surface is depletion. I'll show you some of the very important diagrams I'm taking from. I'm really grateful to the internet and a very famous journal, Nature Review Materials, and I'm taking this diagram of understanding electrified interfaces from Nature Review Materials, one of the best journals related to just to understand what is actually electrified interface or electrical double layer. Of course, they are also using some catalysis. So left hand side part, this is electrode, porous carbon electrode. This black color is porous carbon electrode. Now this red with this some part like that, red and like water. You see here, it is like that. So it is solvent, and there are some green color is the electrolyte anion. Green color is anion, and red color is the cation. You see, there is a mixing, and large number of solvents are also there. You see, of course, the green color are, so that means the electrified interface electrolyte solution is here. So it is the interface in between electrode and electrolyte solution. So therefore we call it electrical double layer. But again I am saying that if we are considering the Helmholtz, मैं अभी बताऊंगा आपको कि तीनों में क्या डिफरेंस है. There is no thermal motion, but According to Ghosh and Chapman, yes, there is a thermal motion. That means that cation and anion can move. How is distributed? That is to be calculated. And there are some, because they are doing some catalysis part, so they are also using some inactive catalysis. This color, golden color, this color. तो आपको जस्ट समझना है. आपको आई थिंक नाउ यू आपको समझ में आ गया कि इंटरफेस क्या होता है. मैं बार बार एक ही चीज को आपको समझा रहा हूँ. अनलेस अनटिल यू अंडरस्टैंड दिस फंडामेंटल कंसेप्ट, तो फिर आपको आगे जो हम डेराइवेशन कराएंगे तो आपको आसानी से समझ में आए. अदरवाइज इट विल बी डिफिकल्ट फॉर यू. So you know this type of. So there is a tremendous ion solvation is also there. Solvated anion और cation, solvated water से गिरा हुआ. ये आपका इलेक्ट्रोड है, ब्लैक कलर का जो है इलेक्ट्रोड, ये इलेक्ट्रोलाइट सोल्यूशन है. अब इसको मैं दूसरे ढंग से आपको समझाता हूँ. लास्ट पार्ट, आफ्टर getting this elementary knowledge of electrified interfaces, now I have to see various theories of that electrified interfaces, or even I can call it the structure of the electrified interfaces. Now, as you know, जब भी मैं आपको कोई बहुत बड़े थ्योरीज या पूरे चैप्टर को स्टार्ट करता हूं, तो मैं आपको बता देता हूं कि आपको क्या पढ़ना है. So, as I told you that the role of capacitance, the role of migration of the ions can be studied, the distribution of the ions can be studied by different theories. And if you see this whole historical development, it was started in 1853 by great scientist by Helmholtz, and there were some problems, and that problem was solved by another two great scientists, Ghosh and Chapman, in between 1910 to 1913, because they separately published two papers. And ultimately, मैंने जैसा आपको इंट्रोडक्शन में बताया, there are some problems. Helmholtz and Ghosh and Chapman. So finally, Stern is a Nobel laureate, of course, physics Nobel laureate in 1943. He actually finalized, given a complete understanding of this electrical double layer. And आप बोल सकते हैं कि what is the definition of Stern theory? It is nothing but the combination of Helmholtz theory and Ghosh and Chapman theory. In Helmholtz theory, we consider it is a compact layer. There is no thermal motion. It is just like a parallel capacitor. Whereas Ghosh and Chapman, there is a diffuse double layer. So Stern theory में compact layer भी रहेगा और diffuse double layer भी. And there are other combinations. I will explain these things. So that is the main theory of all these things. But all these three are considered as electrical double layer. My dear students, I would also like to inform you that in addition to these theories, there are many theories. In 1948 also some scientists developed other theories. But as per your course content, I will concentrate only on the Ghosh, Chapman and Stern model of Stern theory. Do I make my point clear? आपको बहुत सारे थ्योरीज हैं और अभी भी बहुत सारे थ्योरीज डेवलप हो रहा है, लेकिन मैं आपके कोर्स के हिसाब से केवल दोनों थ्योरी को कॉन्सेंट्रेट कर रहा हूं. Now again, it is a very simple information for the common student that it is a comparative development of these three theories. First, you can call this Helmholtz theory is the first traditional model, and it is fixed layer of oppositely charged ions. There is no thermal motion, and one of the most important things is that here is the capacitance is constant, and there is a drop of potential. मैं अभी जब डायग्राम बताऊंगा आपको समझाऊंगा. नाउ फिर हम दूसरे में आ जाते हैं, that is Gauss and Chapman. This is the second important theory. Here there is a diffuse double layer. That means there is a migration, thermal motion of the ions. So it is the example of diffuse double layer. But if you ask me, sir, what about the potential drop? I will say it is not linear, but it is a exponential or gradual drop of the electrostatic potential. And of course, here I can calculate the capacitance. Capacitance varies with the potential and concentration. तो इसमें हम लोग दो फॉर्मूला डिराइव करेंगे, एक हाउ दैट पोटेंशियल डिस्ट्रीब्यूटेड, ions distributed, and second the capacitance, and third, which is the ultimate theory, is a combination of Helmholtz and Chapman. So there is two layer, compact layer भी होगा और diffuse double layer भी होगा. And here, because there are two layers, so therefore if I consider the Helmholtz, तो पहले आपको linear drop होगा potential, and then there is a gradual or exponential, and of course variable capacitance. Now, very important diagram, and अगर इस डायग्राम को आप समझ में आ जाएंगे तो आपको डेरिवेशन करने में बहुत आसान होगा. And I am really grateful to my student, Mr. Abhishek Katendra, Mr. Scholar. He has very nicely prepared this diagram, and let me confess that if you refer many books, many review articles, many internet materials, you will get different types of the diagram. But you have to understand these things. Let me start with that first Helmholtz model. जैसे कि मैंने आपको पहले बताया कि फर्स्ट if I am talking about the positively charged electrode metal, so suppose it is positively charged. So due to the electrostatic attraction, another layer, that is the anion layer. There is no thermal motion. It is a very, very old theory, 1853. Can you remember? 185, very old theory. And so, if you see that there is a red color, that is the potential drop, that is potential drop, you see here. It's very old theory, 1853, but first traditional double layer. ये देखिए, ये there is a, and the distance between these two. So it is just like a parallel capacitor. Normal. Okay. Now I am coming to that second theory, which is 1910. This is the Gauss and Chapman layer. Again, I am talking about the positively. You can write here negatively charged also. Now, there is a thermal motion and random distribution, unequal distribution of the ions. Hydration is also there. Hydration means when that particular ion is surrounded by the solvent. Here you see, if I am talking about this thing, you see here, and there are scattered, some positive ions are also there. Small size scattered is also there. So therefore it is called the diffuse layer. It is also double layer, but diffuse. Here is the compact and linear change. Here you see exponentially, gradually changing. You see this red color. This is the change in potential. I will explain when you derive. Derivation is very big. इसलिए मैं सोचा कि डेरिवेशन शुरू करने से पहले एक लेक्चर में आपको फंडामेंटल को समझाया जाए. नेक्स्ट लेक्चर में मैं आपको पूरा डेरिवेशन करूंगा. गाउ चैपमैन का अलग करूंगा, स्टर्न का अलग करूंगा. So you see that there is a change, and this is the hydration. I can call it a solvated cation. Solvated cation. Then last is 1924. Great scientist, physicist, Otto Stern developed this theory, which is called the Stern model, and you can understand this theory very. It is the combination of Helmholtz and गाउ एंड चैपमैन. सो देयरफॉर आप देख रहे हैं कि हेल्महोल्ट्ज में कॉम्पैक्ट लेयर है, तो यहाँ पे देखिए दो पार्ट दिखा था. अगर इसको आपको, तो कभी आप इलेक्ट्रिकल डबल लेयर को कभी नहीं भूलेंगे, क्योंकि अगर आपको फंडामेंटल समझ में आता है. तो देखिए ये पॉजिटिवली चार्ज सरफेस और हेल्महोल्ट्ज लेयर में उसके साथ ये कॉम्पैक्ट है, ये कॉम्पैक्ट है, देयर इज नो चेंज. एंड एज यू सी दैट देयर इज ए लीनियरली ड्रॉप. तो ये स्ट्रेट लाइन है, ये एकदम नीचे ये स्ट्रेट आ रहा है, यहाँ पे कोई चेंजेस नहीं हो रहा, स्ट्रेट पोटेंशियल ड्रॉप. एंड फिर हम किसके साथ कर रहे हैं, गाउ एंड चैपमैन लेयर, वेयर देयर इज ए सॉल्वेटेड आयन, सॉल्वेटेड cations, negatively charged, positively charged. So there is a distribution, and this is gradually changing. So there are two types of potential change in Stern layer. इंट्रोडक्शन पार्ट में मैंने आपको दो चीज बताया. एक मैंने बताया था आपको इंटरनल हेल्महोल्ट्ज प्लेन, इनर which is very near to that electron. And another part is मैंने बताया कि outer Helmholtz plane away from that electrode, and consider that solvation. So this two is very important. The distance between this D, the distance between these two. I think it is very clear to you what is electrical double layer, what is diffuse layer, and what is the importance of the Stern model. So inner Helmholtz means it is very closer to the electrode, absorb ions at the electrode surface, especially absorb ions without full solvation cell. कोई सॉल्वेशन इसमें नहीं है, नो सॉल्वेशन. बट आउटर Helmholtz plane slightly away from the electrode, passing through solvated ions near the electrode surface, hydrated solvated ions retaining solvent molecules. Why I am talking about the hydrated, is water, solvated, any types of solvent. Now the last part, जैसा कि मैं कोई भी लेक्चर में मेरा आदत होता है कि मैं आपको फाइनल फॉर्मूला को जरूर बताता हूँ. मैं डिराइव नहीं कर रहा हूँ आज, नेक्स्ट लेक्चर में मैं डिराइव करूंगा, लेकिन आपके सामने एक क्लियर कट पिक्चर देना चाहता हूँ कि why we study the electrical double layer or electrified interface, to know or to calculate the capacitance, because there is charge species, dipole difference, dielectric constant, there are so many things, distribution of ions everywhere. So the first, if I talking about the Helmholtz model, again capital C, everywhere I have written the capacitance. So it is C is equal to epsilon 0 and A. Epsilon you can generally call it the dielectric constant of the medium, which is very important for any electrochemical studies. And epsilon 0 is the permittivity of the vacuum. A is the area of electrode and the distance between the charge layer, because it is a compact layer. So again I am saying so many times, I am just the same thing. So this distance is D. Okay. Now I am coming to the next part, the Ghosh and Chapman. There are two formulas. First formula, if you understand, many times I have prepared, I teach you the Maxwell-Boltzmann distribution, Fermi-Dirac distribution, large number of distributions, spectroscopy, everywhere. You see, they're just like the same thing, but here is it potential at distance x, and it is the potential at surface after this migration and diffuse and other things. Exponential kappa x. Kappa is a Debye-Huckel parameter. Tomorrow when I will derive this most important Gauss-Chapman model, I will have to take the help of Debye-Huckel equation, because the assumption of Debye-Huckel equation and the assumptions of Gauss-Chapman are exactly same. Just consider that just like a point mass like that. So it is distance from the electrode x. And but the second, as I know that every time I have to calculate the capacitance. So again, the E, you know that dielectric constant kappa is also the Debye-Huckel parameter. So either Z is the valency electronic charge, K is the Boltzmann constant, and T. So there are that, of course, if you compare the derivation of Helmholtz, Gauss-Chapman and Stern model, I can tell you that, of course, it is not difficult, but little bit mathematics will be required. Poisson distribution law I have to calculate. I have to calculate this. Maxwell-Boltzmann distribution is also there. So there are two formulas. And the last formula, that the Stern model, is not at all difficult. 1 by C divided by 1 by CH plus 1 by CD. Because here we are taking two models, Helmholtz model, so it is the total capacitance for the Helmholtz model, and D is the diffuse layer capacitance. तो आपने क्या समझा? मैं अगर समराइज करूं, today I have discussed the fundamental aspects of electrical double layer and electrified interfaces and some elementary examples. And I also discussed the fundamentals of these three important models and the objective of that model. What is our ultimate objective? To determine the capacity. And I also discussed the general interpretation of जनरल डायग्राम ऑफ दैट इलेक्ट्रिकल डबल लेयर. आपके दिमाग में वो बैठ जाना चाहिए कि कैसे हम इनों को, कोई कठिन नहीं है, इट इज नॉट एट ऑल डिफिकल्ट. एंड आई ऑल्सो गिव द फाइनल फॉर्मूला ऑफ दैट मॉडल and the basic difference between the three models, and some photographs I am taking from the Wikipedia and other things. So thank you very much for patient hearing, and it is the first part and it will continue. So my next lecture will be on Gauss-Chapman model. It is a complete derivation of the Gauss-Chapman model. और मुझे आशा ही नहीं, विश्वास है कि आपने अगर फंडामेंटल को अच्छे तरह से समझ गए तो आपको गाउ एंड चैपमैन मॉडल या स्टर्न मॉडल के डेरिवेशन में कोई तकलीफ नहीं होगा. देयर आर सर्टेन small aspects of the difference between the polarized and non-polarized electrode, the actual definition of electrified interface, what are the applications of, what is the significance of electrified interface, and that is essential and necessary in order to understand the different models of electrical double layer. Thank you very much.